Hello everyone, welcome to Mathematics Talk. In this session, we will be exploring the limit of function using other techniques, and I will be guiding you through direct substitution, rationalization, and factoring. Let us begin.
By the end of this video, you will be able to A. Identify the best method for finding limits, such as direct substitution and factoring. B. Use different techniques to evaluate the limits of rational function. C. Apply direct substitution and factoring to solve the indeterminate forms and simplify complex expressions.
Before we jump in, do you know what the limit function is? The limit of a function is the value that the function approaches as the input approaches a certain value. We have different techniques to evaluate the limit of a function. One of these is direct substitution.
What is direct substitution? Direct substitution is the most straightforward approach for evaluating limits involving the direct substitution of the variable's value into the function in question. This method provides a clear and efficient means of determining the limit. Direct substitution works best for functions that are continuous at the point where you're finding the limit. Now, let's have an example.
Now we have the limit of 6x squared minus 3x plus 1 as x approaches to 3. To find this, we substitute x is equals to 3 into the function. After plugging the value 3 into the function, we need to evaluate this expression. Bring down the 6, then multiply it by 3 raised to 2. Next, multiply 3 by 3 and copy the remaining term 1. After performing the multiplications, we have 54 minus 9 plus 1. And finally, combine the terms and then subtract 9 from 54, then add 1. So therefore, the limit of the function as x approaches to 3 is 46. Now that you understand direct substitution, let's move on to rationalization.
Rationalization. Rationalization is a mathematical technique commonly used to evaluate limits, especially when direct substitution leads to indeterminate form like 0 over 0. This technique is often used with square roots or other radicals to simplify the expression and make the limits easier to compute.
Here we have the limit of x minus 4 over square root x minus 2 as x approaches 4. To solve this, we conjugate the denominator square root x minus 2 by multiplying both the numerator and denominator by square root x minus 2. After conjugating, the expression becomes x minus 4 over square root 2 times square root x plus 2 over square root x plus 2, where the denominator simplifies to x minus 4. Now we have to cancel x minus 4 from the numerator and denominator, leaving square root x plus 2. Finally, we substitute the x is equals to 4, and therefore, the limit of the function as x approaches to 4 is 4. After discussing what rationalization is, let's move on to factoring.
So, what is factoring? It is used to simplify a function when direct substitution leads to an indeterminate form like 0 over 0. By factoring the numerator and denominator, common factors can be cancelled, potentially resolving the indeterminate form and allowing for the evaluation of limit. I'll give you an example to help you understand it better.
Lastly, we have the limit of x squared minus 6x plus 8 over x minus 2 as x approaches to 2. First thing we need to do is we need to factor the numerator. To factor the numerator, we need to find two numbers that when multiplied give a positive 8 and when added give negative 6. The numbers we find are negative 2 and negative 4. Next, we separate the two numbers to create a new numerator, which give us x negative 2 and x negative 4. And now our function becomes x negative 2, x negative 4 over x negative 2. In this new function, we see that the numerator x minus 2 and the denominator x minus 2 are the same, so we can cancel them out. This leaves us with x minus 4. After cancelling, we can perform direct substitution in x minus 4, which give us 2 minus 4 is equals to negative 2. Therefore, the limit of the function as x approaches to 2 is negative 2. Let's take an example. Try solving this using direct substitution and factoring. Take a moment to think about it and feel free to share your answers in the comments below. I hope you learned how to find the limit of a function using different techniques. It's been a pleasure learning with you. Always remember to keep exploring and practicing your skills. Thank you for watching.